thank you, Mark, thank you, Ryan, thank you, sponsors. I'm really happy to be here. I've been in the Southern Hemisphere one other time in my life, but it was in Peru. So I haven't spent too much time in this region, but I'm really excited to be here. It's a beautiful country, and I'm really excited to share with you the ways that I think we can improve the world through decentralization. And this goes beyond just Ethereum as a blockchain. There are other components to decentralization, and I think actually we can make a huge world impact through our businesses, through the ideas and dreams we have. So let's get started. So first I want to talk about, just real briefly, because we've glossed over it a little bit, Satoshi Nakamoto and Bitcoin. Satoshi's gift to the world, effectively, was this Bitcoin, this idea of a chain of blocks. And in fact, these are the words he used in the paper he wrote. He never said blockchain. Blockchain was a notion that came after the fact, once we started to explore this idea a bit more and understand, okay, well, what exactly is going on here? So, Bitcoin was released January 3rd, 2009. It was discussed on some developer mailing lists and things of that nature beforehand, but the actual release, not too long ago. It was an intentionally limited scripting language. The concern was, hey, we have this whole new idea, this new technology. Let's not break it as fast as we can. We want to make it resilient as possible. So the scripting language with Bitcoin is limited for a good reason. It also had a 10-minute verification time. Now, today, 10 minutes seems like a bit long compared to what Ethereum can do, but looking back, actually, 10 minutes was a huge improvement over what banks were offering, which is maybe 1 to 3 day settlement. Or if you're a merchant and you accept credit cards, you might be looking at 60 days to get your money. With Bitcoin, you could do this in 10 minutes, at the most 60. So Bitcoin worked for a long time, and it wasn't actually until a little over a year later that the first value transaction happened. What do I mean by value transaction? Well, Bitcoin, 10,000 Bitcoins, in fact, were traded for pizzas. You might have heard about this. And Bitcoin was finally valued at that point because someone said, yeah, I'll take that crazy internet money and I'll give you some pizzas. So at this point, Bitcoin was probably valued at sub-penny. Compare that today to $400+ plus. Quite a long haul. So now Ethereum. Ethereum was kind of the next step. Vitalik Buterin wrote about what he envisioned for a next generation blockchain and published this in a white paper around November, December 2013. As compared with the limited scripting language of Bitcoin, he wanted, and I wanted, and a lot of other developers wanted, that actually we could build anything we want. And this is the idea of Turing-complete programming language. Turing-complete is named after Alan Turing, which is one of the early computer scientists that realized, hey, yeah, we can build a physical machine with gears and cogs and make it work, but what's much better than that is to make it programmable in a way so it can do any operation. And that's what we have with Ethereum. You can put anything on Ethereum that you can represent mathematically or in a computer program. So after having seen what Bitcoin could do and waiting for the research to come out and seeing that actually we can go much, much faster than 10 minutes. We can go all the way down to a few seconds or 1 second. Maybe that's a little risky for this early, but finally we settled on a time around 15 seconds. I think now it's about 14, and we'll probably see that decrease a little bit over the rest of this year. Looking forward, we might actually see sub-second time, which if you think about just a web page and clicking a button, most of us as humans, I think about 2 seconds, 2.5 seconds is about what we're willing to wait for a response. So if we can get blockchains down to 1 second, that could be very, very meaningful. And finally, I want to mention that Ethereum, although it was envisioned in 2013, it was finally released less than a year ago, in July. So now we have Bitcoin, now we have Ethereum, now we have blockchains. What is a blockchain? Well, after doing a lot of talks and discussing with people and trying to narrow down this definition, I've come up with a 3-word elevator pitch. It's a distributed, immutable ledger. It's distributed because everybody participates. It's immutable due to the cryptographic properties, so no system administrator can go back in and change it after the fact. And it's a ledger, something that we use for accounting, tracking of titles and assets. But specifically, when you put these things together, you get something that excels at coordination. And one of the metaphors that I kind of explained to one of my colleagues in China was, yeah, you have all these parts in an automobile, right? Steel and the wheels and the windshield glass. That's fine. You can have a bunch of parts, but it's not an automobile unless you assemble them in a certain way. And that's how I feel about blockchains. We have these technologies, and we'll go through them here in a little bit, but unless you kind of construct them in a very specific way, it's not meaningful in the same way. So when you have this technology that excels at coordination, it does it especially between mutually distrusting entities. And that's because we kind of delegate the trust that we would normally have between us as humans, seeing each other face to face. We delegate that to the protocol. So we can worry about our interaction and how the interaction is supposed to go, and not about your reputation or what happens if you try to steal from me. We can let the protocol handle that. And one other key feature of blockchains that I think is very underappreciated and perhaps under-discussed is the idea of digital uniqueness under owner authority. So what do I mean? Digital uniqueness. Computers gave us a way to copy information very readily. In fact, that's a huge problem, right? The recording industry and the motion picture industry, they don't really like the fact that you can copy information readily, and they've tried to fight that. So what this distributed immutable ledger does is actually gives us a way to represent digital uniqueness, which I think is really interesting because it allows us to replicate what we have in the real world online. But this under owner authority thing is the really interesting part. We could have digital uniqueness before. Our governments track our health service number or social security number, right? That's uniqueness. It's probably mostly digital, but it's governed by a central authority. So in the case of blockchains, you can still have this digital uniqueness, but it's under our own individual authority. You, the user, control it. Me, the user, controls it. Everybody as users control it, not a central intermediary. It's kind of the next logical idea built on top of blockchains. This is a term coined by Nick Szabo in the early to mid-90s. And actually, he was the other one who kind of came up with this idea of under owner authority, which I stole from him a little bit. But essentially what we have is code or contract enforcement on blockchain. Because we have delegated this trust to the blockchain, to these smart contracts, we can actually mitigate a lot of loss and forgery because the protocol ensures that things are done the way they're supposed to be done. And if we look a bit forward, and we'll talk about this in a few slides, is there's actually going to be many applications with the Internet of Things. That's this IoT up here, if you're not familiar with it. And also this M2M that I put down at the bottom. I'm sure many of you are familiar with B2B, B2C, business to consumer. Well, one of the things that we're going to see come out of smart contracts and Internet of Things is machine-to-machine transactions. And if you think about the number of legal contracts that we establish between ourselves as humans, I think it's going to be a drop in the bucket compared to what digital devices are going to negotiate and execute as far as contracts between themselves. I think we're going to see exponential growth in the way that contracts are executed when they're done on blockchain. And finally, DAOs. Mark talked about this a little bit earlier in the day. These are distributed autonomous organizations or decentralized autonomous organizations, if you prefer. They're community-supported digital entities. There's a group of people that coalesce around an idea, and they decide, yeah, let's use these smart contracts. Let's use these to build a community and an ecosystem around whatever it is that we're interested in. Thinking about the DAO that has raised 125 million now, all the people that are participating in that DAO are interested in helping other projects get off the ground, whether they be Slockit, whether it be a prediction market, whether it be something that we haven't thought up yet. But basically, they're organized around shelling points of functionality. If you do a bit more digging into the blockchain world, you realize that actually a lot of the things we talk about deals with this shelling point. And just as a really basic example, I'll tell you, so if we drop 10 people off in the middle of, or spread around Auckland, and ask them, hey, 10 of you people, if you all meet up, we'll give you each $1 million, okay? It's really strong incentive to collaborate and figure out how you can do that. But they're not in a group, right? You know, some people might be out on the harbor, some people might be in another area of Auckland, right? They all have to find one place to go to. So where do you think that maybe people would meet up? Any ideas? In the center, that's one possibility. Sky Tower, yeah? Actually, that would be my vote. Sky Tower, it's 328 meters tall. It is the largest man-made structure in the southern hemisphere, as I looked up on Wikipedia. So, so if you're in a random spot in Auckland, what's going to be the most visible thing? It's going to be that giant tower. So there's a really good chance that no matter where you were dropped off, you're going to meet up at this place, and if all 10 of you are correct, bam, you've all got $1 million. I think that's a really cool idea, and a lot of the whole economics of blockchains work around this shelling point idea. So to get back here to the idea of DAOs, DAOs basically allow for transparent governance on-chain. This is if you want it. Not everybody wants this, but there are really great use cases to have transparent governance on-chain. Anything that's a public utility, I think, is a good case for it. Anything that's a nonprofit foundation, I think people want clarity in how the money is spent. So by moving these structures onto blockchain, you get much better transparent governance. So that's all great. We've been hearing about these ideas for most of the day, but are blockchains actually a solution in search of a problem? What do they solve? If you go ask somebody on the street about blockchains and explain to them decentralized, autonomous organizations, they probably aren't going to care. They're probably going to say, how does that impact me at the end of the day? And I kind of want to explain that as we go through the presentation here and try to communicate the idea of how might this impact you or your business. So I'm going to do this actually by breaking this down into a problem statement of 3 areas that I see issues with the internet. And why I start with the internet and not the world in general is because blockchains can't really exist without the internet. Passing around cryptographic information by hand would be excruciatingly painful, to say the least, without communication mechanisms. So thinking about the internet, we have a problem of lack of transparency in certain areas. We also have a lack of privacy in other areas. Right? In the real world, you can walk into a separate room, have a private conversation, and no one hears it. But we know that's not the case on the internet today. We also have a problem of lack of access or free speech for some. Many areas of the world, like this one, people more or less have unfederated access to the internet. But if you go to China, you know, they have a great firewall there. You go to other places that don't have readily access to the internet. And I think, you know, on principle, it's a good idea to enable access to these technologies, but because it enables trade, which raises the economic votes of everyone. So, how can technology help with these problem statements? I'll go through real quick and just explain some of these ideas and maybe draw some metaphors of actually how they represent real world problems. First is asymmetric cryptography. This is exceptionally important on the internet today. If you've ever bought anything online and you see that little padlock in the corner of your browser, you're using cryptography. It allows for a couple of key functions. One is signing and verifying. What does this mean? Well, if I sign a legal contract, I write my name, that's the signing. And if you want to make sure that I actually signed the contract, you will compare it to an existing signature and verify it. So cryptography allows for signing and verifying of information. It also allows for encryption and decryption. So if you want to have a private conversation, you take your message, bundle it up in a certain way so only the recipient can decrypt that message. Anybody else who sees it we'll just see basically garbage. So encryption and decryption allows to solve some of this privacy aspect. We've heard a little bit today about peer-to-peer, not having a centralized intermediary or central server to control operations. This gives us a couple properties: censorship resistance and fault tolerance. So in a traditional structure, if you had maybe a master database and a replication database, if one of those goes down, you're in real trouble. You've got a backup, but if that goes down, you're dead in the water. When you work in a peer-to-peer system, you might have hundreds or thousands of nodes. If half go offline, that's okay. You still got hundreds or thousands of nodes carrying on the operations. So you get a lot of resilience and fault tolerance from this. And lastly is triple entry accounting. I was speaking with the ambassador a little bit earlier today, and one of the things I mentioned to him that I think auditors and regulators should be very interested in is this idea of triple entry accounting. This is a term that a gentleman by the name of Ian Gregg came up with, I think around 2005. The idea is you can get increased transparency here because you use a cryptographic digest as a receipt. So actually this cryptographic digest kind of belongs at the top here with the asymmetric cryptography, but I grouped it down here with the accounting part because in a triple entry accounting system, you go one step further than what we have for accounting now: debits and credits, double entry accounting. For every debit, there must be a credit. But there's a problem with this. Somebody who has access to those books can go back and change it after the fact. They can go back and make changes. Now, it might be a little difficult with the double entry accounting, but it's certainly possible. This is de facto impossible when you use a cryptographic receipt. If you change one character anywhere in the document, the message digest changes completely. So if we use this cryptographic digest as a receipt, it's a triple entry, a third piece of the accounting puzzle, we can actually solve lots of problems that we have with transparency where we want it. So talk really briefly about the importance of these. Individually, they are important, but they are not exclusive to blockchains. In fact, most of these technologies have been around for quite some time. Cryptography has existed in many forms since the Roman times, really. Modern cryptography has been around for several decades. We've seen people try to use it with email and messaging, but it hasn't really taken off. What I would say is really the opportunity here is to combine these sets of technologies in a way that provides more value than they provide individually. And think about the car metaphor, right? You have steel and glass and all these other things. You can have them in a pile, but it's not an automobile unless you put them together in a certain way. In the same way, if we combine these technologies, we combine these solutions, we can actually build a bridge to a much better place. In the end, ideally, as a technologist, one of the things I would like to do is provide concrete benefits to overcome less secure legacy technologies. And when I say overcome, I mean to overcome the network effect of people using plain text email, of using unencrypted websites. If we give people enough reason to move to a new system, maybe they'll actually move. I've talked to my mom, who's not very technologically inclined, and the one thing that she actually appreciates about decentralization is this idea that we can have privacy in a way that we don't have now. We don't have to be constantly hacked and have our data stolen. We don't have to be spied on by governments that we don't want. We can provide the same kind of real-world benefits online. So thinking about these technologies, thinking about blockchain and smart contracts and DAOs, you can see that this builds way beyond programmable money. It builds beyond a peer-to-peer network that's just like BitTorrent, right? Actually, if we assemble all of this stuff together, we can create a world computer. So just real quick, I saw some numbers this weekend, I think it was, about the growth of computing through mainframes and PCs. And I kind of, I don't know, it highlighted my attention because of the world computer vision, the Ethereum vision, and what that means for where we've come from technology in the past. So if we look at mainframes, there was an estimated 100,000 mainframes at one point. Those were primarily processor machines. They did computation for us. Once we added disk, so things could be remembered, at that point, we had the growth to about 10 million PCs, so a factor of 100. And now we have this networking component, right? Now they can interact and talk with each other, and we have an estimated 6.5 billion laptop mobile devices, which includes, our phones. But you can break this down, this processor disk network thing, and abstract it into logic, storage, and messaging. This is actually what the Ethereum vision is building towards. It's beyond the blockchain. Actually, there's a decentralized storage component and a decentralized messaging component. And this is really where the power comes in of building decentralized applications. So most of the stuff you've heard about today, the Ethereum blockchain is what we talk about in the inner circles, the EVM, the Ethereum virtual machine. Swarm is the technology to have decentralized storage, and Whisper is the decentralized messaging. I think that with the growth of IoT, Internet of Things, with the estimates of 10 billion plus devices, building these kind of systems are going to be monumentally important. Thinking about how these devices negotiate with each other and the need for smart contracts that they can automatically execute is going to be very, very important to allow that to occur. So what are some of the opportunities here? Well, the vision is to recreate these possibilities atop modern technology and allow for a re-engineering of the web. And I don't mean that to throw out what we have with the web. The web's really great. Tim Berners-Lee is one of my heroes, came up with the whole idea of this hyperlinked web. I think it's really good. I just want to swap some of the protocols underneath. I want to take the engine out of the car and put in the electric battery pack, right? I think that's what we can do here. We have this opportunity to kind of swap that out and go from these old systems to some new systems that better serve our needs today. And one of those things I just want to highlight is this idea of the cloud. We see these diagrams illustrated with this kind of dotted line cloud, and the information goes through it. But that's not really a good representation of what actually happens. The cloud, as we think of it today, is primarily controlled by large organizations. Amazon, Microsoft, things like that. Your data is stored with them. And if they decide to turn your machine off, too bad, you've lost your data. So what we really need is a cloud where, thinking about this owner authority, where you, the user, control the data. So I'd like to build a better cloud, and in that process, resisting the control of malicious entities. That might be governments, that might be corporations, that might be other individuals who are trying to censor your views or opinions. But the idea is that by having open access and free speech, we can resist control by malicious entities and ensure we can all communicate as we desire. So, taking one step further, thinking about blockchains, let's say, okay, this blockchain thing, maybe it will actually happen. If it does happen, what will the world look like? Well, I look at the world and the world computer as a global trust machine. It's an internet OS of sorts, but it's a decentralized internet OS. There have been a lot of organizations who've tried to build like an OS in the cloud, but I can't trust my data to it because eventually they all shut down. But when we have this global trust machine, it will allow for distributed computation around mutual agreement. And again, the user will own their data. So we've had lots and lots and lots of metaphors. I want to talk about a few practical use cases. I like to dream of all the kinds of things we can build with a system, but at the end of the day, you're probably here to understand how this practically applies and to you and maybe the person on the street. Let's look at the 20th century inroads. We went from a physical desk with secretaries and office workers and all of that stuff, and now we've moved into an era where my entire desk has been digitized. And in fact, if you log into pretty much any desktop or laptop, what are you greeted with? A virtualized desk. It's right there. You log in, it's clear desk, or in my case, lots and lots of files and folders, because I'm messy in that way. But if you want to interact with the system in any other way, you have to kind of dig into the menu and find the right people or files. It's a really messy system. And it's a carryover from, I think, 1960s, 1970s design and technology. I think we can move past this, and we are moving past this now. The App Store model shows that the digitized desk metaphor does not hold up forever. We could also solidify the semantic web that was the dream of Sir Tim Berners-Lee with rich metadata and linking of correlated data. When you look at a web page today, you see all kinds of styles and bold and italics and different colors, but actually behind the scenes, there's text and it's surrounded with some markup, and that markup gives the meaning to that text. Maybe, for example, it's a quotation. A quotation should be set aside and be visually different than a paragraph. But behind the scenes, there's actually an HTML tag called block quote, and that's different from normal text, which is paragraph, right? So this is what is the semantic web and giving meaning and context to data. So I think with the blockchain as a decentralized database, we can move even further with this metaphor and make sure that the information that's out there has context, and that context is going to depend on who you are and what's important to you. So a few possibilities if we think about this. I mentioned the message digest earlier, and how if you just change one character, the whole digest changes. Well, we can do something like this. We have technologies like BitTorrent and now IPFS, which is Interplanetary File System. You can take a document, get a message digest, and actually just pass that message digest around. It's very compact. You can actually write it down on a piece of paper, right? So you can pass this identifier around, and you see these kind of technologies with Google Docs or Dropbox, right? You can mail a link around instead of the document itself. It's really useful unless Dropbox is offline or unless Google's not available in your particular country. So if we do this with a decentralized system, we can get rid of the intermediary that may not be accessible to us where we are. I think this is a really, really powerful idea. Traveling quite a bit, have to do quite a few expense reports, and there's nothing I hate more than dealing with receipts and copying information into different systems, and emailing that to somebody else, and then them asking for more documentation. And every step along the way, we're losing fidelity of that information. Think about, printing out a document, signing it, scanning it, and sending it. Your signature is not going to be perfectly what it was on a piece of paper. But we can move past this, actually, because we don't have to do this process of printing out into a physical form and then rescanning into a digital form and then moving it around some more. We can just point to the document with a single identifier. We can also track changes over time with a shared ledger. So let's think about the example of a collaboratively edited document. You have a document, you send a link to it to your coworker, they decide, we can make some changes to this document and improve it. They make their changes, a new unique identifier is generated, and you can see those changes being tracked over time. Now, we do have systems like this today, but they're not as robust, they're not as universally acceptable, and if they decide to seize or shut down your data, you're out of luck. So, using Message Digest to track documents on a shared ledger is really great. It gives us a perfectly auditable log of events. So again, if you're a regulator or auditor, this is something that you're going to want to see. And finally, granular access control with modern cryptography. It's a lot of words, but what it means is that I can hand the document out, and even though you might be able to read it, it doesn't necessarily mean that the person sitting next to you can read it. And I want to take that idea further so that perhaps we could get to a point where when we share some information, I can give you just a subset of that information. And I'll give you an example a little bit later about how this could apply to health systems. It's important to note that this is really improving upon what PGP and OTR attempted. If you're not a technology person, this stands for pretty good privacy and off the record. They were encryption systems for email and instant messaging, but they didn't take off for a variety of reasons, the least of which probably wasn't the fact they aren't very easy to use. I use them today, and they're still really difficult, and they've existed for 30 years, so what's the problem here? So what I'm kind of getting at with a lot of these ideas is actually reimagining the back office. We can streamline and make the back office much more efficient. There's a lot of opportunity to gain efficiencies out of some administrative aspects of any business or process. We can, as I mentioned, instead of emailing a document around, just send the identifier, or even better, be notified when an edit to a document you care about has occurred automatically. And they can also be universally acceptable. I would love to eviscerate fax once and for all. I hate the fax machine. I don't know why we still use this thing. It's enshrined into law, of course, because you can, sign this, send it over the phone line, and somehow that still counts as a valid legal contract, which I get, I understand, but what's the problem here? Every time we send this fax around, we're losing fidelity. The image that gets scanned and sent through is not a perfect copy. So when it comes time to actually verifying a signature, how do you tell what's a forgery and what's authentic? I don't know. But digital signatures don't have this problem. There's zero loss of fidelity with digital signatures. And again, just to reiterate, independence from provider shutdown seizure. Be a really great feature. So, some real-world industry impacts. Healthcare. This is something I'm passionate about. My mom is a nurse. I have grown up around the healthcare system my entire life. I remember spending days in the emergency room, not because anybody was hurt, but because my mom was working there helping other people. But now as an adult, I have to deal with all these systems myself. And I recently went into the doctor, and it was a new doctor. So what does that mean? That means I have to fill out a form. Actually, I have to fill out 4 or 5 forms. And if I decide to go to a dentist, I'm going to have to fill out probably 2 or 3 very similar forms. And if I have to go to a specialist, you guessed it, I'm going to have to fill out more forms. Now, why am I filling out my name and address on every single form every single time? This seems a bit ludicrous. And furthermore, I don't even actually have control of the information that I've just handed over. I go see the doctor, they create some information in a medical record about me, and if I decide to change doctors or go see a specialist, how am I supposed to get that information and data over to them? I can ask for a copy, again, copy, loss of fidelity, take that information, physically walk it over. Perhaps today we're starting to build towards digitized systems, but even if the doctors communicate that information automatically, who gave them the permission to do that? And who's on the other end at the doctor's office that's able to see that information? I don't particularly like this. I would like the data to be under my own authority where I can grant and revoke access at will. If I decide to leave a doctor, they more or less have a copy of my records. I should be able to just log online and say, revoke access from doctor. Problem solved. Another one is the legal system. Efficient execution of contracts is kind of the impact I put here. It's not entirely clear what the impact to the legal system is going to be in terms of blockchains. I don't know if governments are going to accept a digitized version of a real-world contract. Maybe if they exist in parallel for a while until this idea takes hold more and people accept them more. But I think that lawyers, attorneys are going to have to answer this question of what does smart contracts mean to the legal system? For now, I would say it's an efficient execution of contracts. If you can negotiate a contract and put it into code, you know that contract is going to be executed as it was defined there. Another one is title tracking, which was mentioned. You have an incorruptible log of ownership. So if you buy or sell a house, a car, anything substantial, no one can change that information. No corrupt government official can give themselves access to beachfront property. So I think this is really important, and it's low-hanging fruit. I think it's very obvious how to use a ledger to track these things. Let's just stop using paper and start using digital. So finally, supply chain management. This has a variety of implications. Provable sourcing and manufacturing is extremely important for a variety of industries. If you think about coffee or diamonds, right? People kind of are shying away from blood diamonds. They would rather purchase diamonds that have a good path of sourcing. And this is really interesting because if you are involved in this process and you have a supply chain behind your business, you know people are willing to pay for the story behind the good or service that they're procuring. So if you can tell a better story of how that item came to be in that person's possession, and if you decide to divest yourself of that item by selling it to somebody else, you have a perfect log of where it came from all the way through all the owners. So you have that story behind the item. I think it actually adds value. If you're in the supply chain business in any way, you should be really interested in blockchains to help show the sourcing and manufacturing over time. Okay, a few more slides. I think I'm more or less out of time, but I want to talk about a quick glimpse of the future. So we've talked about a lot of concepts. The world computer, what is it? In a summary, I would say it's a global trust machine with guaranteed execution that can be secure by default and is censorship resistant. If we bundle all these things together, I think we might have a good use case to let people know, hey, the internet is kind of broken, we need to re-engineer it just a little bit, and we actually have a pretty good system that solves a lot of the problems we face today. So let's give it a try. But the world computer is just the tip of the iceberg. I mentioned Internet of Things a lot. One of the other areas of great interest is virtual reality and or augmented reality. So if blockchain can be used to track the real world change of ownership, right, like a piece of property, why couldn't you use augmented reality to do something similarly? People could control virtual space. Maybe not our ideal world, but I'm sure marketers would love to control some piece of land, and if you're wearing your virtual reality goggles, you would see their advertisements. That's an entirely perfectly legitimate use case of blockchains. Futarchy is a kind of new style of perhaps governing ourselves that relies on prediction markets. We heard about Jack talking about Augur and prediction markets. Vote on values, bet on beliefs is effectively what Futarchy suggests. And if we can govern ourselves in that way, it will be a really interesting system. I don't know if we can, but at least with blockchains, we can try it if we desire. The sharing economy was also mentioned. Uber, Airbnb as central intermediaries. They can be disintermediated. Their fees can be lowered. We don't have to rely on them to provide that specific service. We can interact with lots of people in a peer-to-peer way and sharing our reputation along the way. So if I have reputation at eBay and I've just signed up for Airbnb, no one trusts me. But it would be really nice if my feedback on eBay provided just a little bit of reputation on Airbnb or Uber, at least until my reputation on those systems built up. And we effectively don't do that because of the siloing of the information. But blockchains allows this hyper-interconnected data sharing. Prediction markets, and also one area that I'm particularly interested in is autonomous personal assistance. This would be like, kind of like a Siri, but Siri is pretty dumb. Sorry, Apple. I think that autonomous personal assistants could be really interesting because they could watch your behaviors over time, the behaviors that you give them access to watch, right? And it can start to suggest things that you might need before you even realize you need it, right? And this is using things like machine learning to predict, okay, it's in the spring, you're running low on soap, this is a time to clean your house for most people, so perhaps you want to order soap because there's a deal on Amazon right now. This is something that I want, so I have to make less decisions in my life. Okay, so final slide here. World impact. Bring it all together. So in the end, what can we do with all this? I think there's a variety of areas we can go with this technology, but at the end of the day, the thing that I'm passionate about is bringing low-cost coordination technology to impoverished areas. If you think about people who don't have access to good governance systems, blockchains and coordination technology will allow them to self-govern, to communicate amongst themselves, and to reach out to perhaps nearby neighborhoods. And when their government isn't providing the kind of service they need, they can provide it for themselves. This is something that's quite hard, actually, without the internet. We can also ensure privacy for all netizens. So I want to be able to walk into a side room and have a private conversation without spying agencies seeing what that is. And I would also like to guarantee access through anti-censorship principles. In summary, I want to encourage collaboration from local to global. Thank you very much.